Hello students, welcome to my channel Halla Bol Physics. Okay, today's topic is relation in between change in temperature on centigrade scale and on Fahrenheit scale. You know here one relation, C is equal to 5 by 9 of F minus 32. Everybody know that relation now. Where C is the temperature on centigrade scale, F is the temperature on Fahrenheit scale. What is the use of that relation? To convert centigrade scale into Fahrenheit scale or Fahrenheit scale into centigrade scale. But our question is not that. How to convert one change in temperature into another change in temperature? One change in temperature into another change in temperature. Yes, this relation will be helpful to convert one change in temperature into another change in temperature. But how it is, we will discuss in a class now here. Yes, C is equal to 5 by 9 of F minus 5 by 9 into 32, multiplying inside it by 5 by 9. Tell me now, yes, if C is equal to C1, if C is equal to C1, yes, it is 5 by 9 of F will become equal to F1 minus 5 by 9 into 32 is a constant term. So if C is equal to C1, F will become equal to F1. In the same way we can take here, if C is equal to C2, it is 5 by 9 of F will become equal to F2 minus 5 by 9 into 32, this is constant term. So if C is equal to C1, F will become equal to F1. If C is equal to C2, F will become equal to F2. These are two relations we are developing now here. Suppose relation number 1 as a relation number 2. Now, either 1 minus 2 or 2 minus 1, we can take it now. Suppose we are taking 2 minus 1. 2 minus 1. What is 2 minus 1? Is C2 minus C1. C2 minus C1 will become equal to 5 by 9 of F2 minus F1. You can check it here, you will get the same result here. So C2 minus C1 is equal to 5 by 9 of F2 minus F1. This C2 minus C1 is the change in temperature on centigrade scale. Yes, it is represented by delta C and it is equal to 5 by 9 of F2 minus F1 is the change in temperature on Fahrenheit scale, which is represented by delta F. So delta C is equal to 5 by 9 of delta F, where delta C is the change in temperature on centigrade scale and delta F is the change in temperature on Fahrenheit scale. Now this relation will be helpful to convert one change in temperature into another change in temperature, or this one change in temperature into another change in temperature. We can convert delta C into delta F or delta F into delta C with the help of this relation. Okay, now we can discuss few questions related to the change in temperature on centigrade scale and on Fahrenheit scale. Okay, first question now here is centigrade and Fahrenheit scale both are dipped in boiling water. Yes, both are dipped in boiling water. The water temperature is lowered until the Fahrenheit thermometer registers 167 degree Fahrenheit. Then the fall in temperature on the centigrade scale is, fall in temperature is the change in temperature. Fall in temperature is the change in temperature. You know, fall in temperature, rise in temperature is the change in temperature, is the change in temperature. So fall in temperature is nothing but a change in temperature which is required on centigrade scale. So delta C is required. What is required? Delta C. Now, centigrade and Fahrenheit thermometer both are dipped in boiling water. Both are dipped in boiling water. Yes, we have taken one diagram on the board here. This is, suppose centigrade scale is a Fahrenheit scale and both thermometers are dipped in boiling water. What is the meaning of this here? When both thermometers are dipped in boiling water, initially both thermometer will have upper fixed point. Both thermometer will have upper fixed point. What is upper fixed point on centigrade scale is 100 degree Celsius. What is upper fixed point on Fahrenheit scale is 212 degree Fahrenheit. 212 degree Fahrenheit. Now, the water temperature is lowered. Yes, water temperature is lowered until the Fahrenheit thermometer registers 167 degree Fahrenheit. So water temperature is lowered until the Fahrenheit thermometer registers 167 degree Fahrenheit. So this value is 167 degree Fahrenheit. Now the question here, when the reading on this scale is 212 degree Fahrenheit, what is the reading on centigrade scale is 100. What is the reading when the reading on Fahrenheit scale is 167 degree Fahrenheit? Suppose reading on the centigrade scale is x degree Celsius. Now, what is this here is the change in temperature on Fahrenheit scale. This is nothing but a change in temperature on Fahrenheit scale. So, this is the value of delta F. Delta F is the change in temperature on Fahrenheit scale. Now, if it is delta F, what is this one is delta C. What is delta C? Is the fall in temperature. Delta C is the fall in temperature on the centigrade scale. So, if it is delta F, this value will be delta C. Now, what is asking part here? Not asking x. What is asking? Delta C, because delta C is the fall in temperature. Delta C is the fall in temperature. So delta C is required, not required x. Not required x. So what is delta C is equal to 5 by 9 of delta F. This relation will now be helpful to give the answer of our question here. You know, delta C is the required part here. It is 5 by 9 of what is delta F is the change in temperature on Fahrenheit scale. What is change in temperature on Fahrenheit scale is 212 minus 167. So this value is 212 minus 167. Okay, one more question now here. A centigrade and Fahrenheit scale both are dipped in water at 0 degrees Celsius. Both are dipped in water at 0 degree Celsius. The water temperature is raised. Water temperature is raised until the Fahrenheit thermometer registers 140 degree Fahrenheit. Then the rise in temperature on the centigrade scale is. Now what is asking part here? Rise in temperature on the centigrade scale is nothing but as change in temperature on the centigrade scale. Now one thing is mentioned in the question here. A centigrade and Fahrenheit scale both are dipped in water at 0 degree Celsius. Yes, what does it mean by this here? When both thermometers are dipped in water at 0 degree Celsius, yes, there will be the lower fixed point of the both scale. There will be the lower fixed point of the both scale. So what is lower fixed point on centigrade scale is 0 degree Celsius, and the lower fixed point on the Fahrenheit scale is 32 degree Fahrenheit. 32 degree Fahrenheit. Now the water temperature is raised. Water temperature is raised until the Fahrenheit thermometer registers 140 degree Fahrenheit. 140 degree Fahrenheit. Now listen here. When the reading on Fahrenheit scale is 32 degree Fahrenheit, what is the reading on centigrade scale is 0 degree Celsius. When the reading on Fahrenheit scale is 140 degree Fahrenheit, reading on centigrade scale is x degree Celsius. X degree Celsius. Now from the diagram it is clear here, this is the value of change in temperature on Fahrenheit scale. It is represented by delta F. This is represented by delta F, and here is the change in temperature on the centigrade scale. So this is the value of delta C. What is delta C? Is the change in temperature on the centigrade scale. So from the diagram it is clear, is the change in temperature on Fahrenheit scale and is the change in temperature on the centigrade scale. What is asking part? Delta C. Okay, a relation will now be helpful. Delta C is equal to 5 by 9 of delta F. That relation we discussed already in a class here. So what is the rise in temperature on the centigrade scale is? Delta C is asking, it is 5 by 9 of, what is delta F is? 140 minus 32 is the change in temperature on Fahrenheit scale. So it is 140 minus 32, or delta C is equal to 5 by 9 into 108. So what is the value of delta C will become equal to 60 degree Celsius. So this is the change in temperature on the centigrade scale, or you can say is the rise in temperature on the centigrade scale. Okay, topic is radiation pyrometer. You know, radiation pyrometer is also known as pyroheliometer, is also known as pyroheliometer. Now question is arising here, radiation pyrometer is based on which principle? Radiation pyrometer is based on which principle? Yes, how to discuss here the principle of radiation pyrometer? As by the name it is clear here, this is mention radiation. What mention here? Radiation. It must be clear in a class. Stephen's law is based on the principle of radiation. Stephen's law is based on the principle of radiation. So this thermometer is based on the principle of Stephen's law. Yes, is based on the principle of Stephen's law. Now what is Stephen's law? Yes, E is directly proportional to T to the power 4. E is the energy radiated per second per unit area. E is the energy radiated per second per unit area is directly proportional to the fourth power of absolute temperature. Fourth power of absolute temperature. So this relation was given by Stephens. That relation was given by Stephens at very high temperature. At very high temperature. E is also known as intensity. E is also known as intensity. Energy radiated per second per unit area is also known as intensity. Is also known as intensity. Now question is arising here, yes, which thermometer is used to measure very high temperature? Yes, no doubt, this thermometer is used to measure very high temperature. Radiation pyrometer is used to measure very high temperature. Now again question is arising here, which thermometer is used to measure the temperature of sun? Which thermometer is used to measure the temperature of sun? Yes, it is radiation pyrometer. Its another name is pyroheliometer. Pyroheliometer is used to measure the temperature of sun. Now what is the temperature range? Is 1073 Kelvin to, yes, it is 6000 Kelvin. This is the temperature range of a radiation pyrometer. This value we can take here in degrees Celsius. Its value will become equal to 800 degrees Celsius. Now one important question possible to arise now here. Why radiation pyrometer cannot measure the temperature below 800 degrees Celsius? Below 800 degrees Celsius. Radiation pyrometer cannot measure the temperature of a body having temperature 500 degrees Celsius. So our question here now, why radiation pyrometer cannot measure the temperature, yes, below 800 degrees Celsius? Simple reason behind it here, below 800 degrees Celsius radiation is low. Radiation is low. So due to low radiation, this thermometer cannot measure the temperature below 800 degrees Celsius. Below 800 degrees Celsius. Okay, next thermometer is vapor pressure thermometer. Which thermometer? Vapor pressure thermometer. Yes, you know, for vapor pressure thermometer, log of P is equal to A plus BT minus C upon capital T, where P is the saturated vapor pressure. A, B and C are constant term. A, B, C are constant term, and T is the absolute temperature must be into Kelvin. Now question is arising here, which thermometer is used to measure very low temperature? Yes, it is vapor pressure thermometer. Vapor pressure thermometer. Yes, vapor pressure thermometer is used to measure very low temperature. Very low temperature. Now, what is the temperature range of vapor pressure thermometer? 0.71 Kelvin to 122 Kelvin. 0.71 Kelvin to 122 Kelvin. This is the temperature range of vapor pressure thermometer. Okay, next thermometer is magnetic thermometer. Okay, before discussing magnetic thermometer, one question is arising here now. Which thermometer is used to measure very low temperature? Very low temperature. Suppose vapor pressure thermometer is not given in the option. As we know it here, vapor pressure thermometer is used to measure very low temperature. So in 4 options, if vapor pressure thermometer is not mentioned, then which thermometer is also used to measure very low temperature? No doubt, yes, it is magnetic thermometer. Magnetic thermometer is also used to measure very low temperature, less than 1 Kelvin, less than 1 Kelvin. So value will be less than 1 Kelvin. Now, what is the principle of magnetic thermometer? Yes, it is based on the principle of Curie law. Magnetic thermometer is based on the principle of Curie law. You know, according to Curie, magnetic susceptibility is inversely proportional to the absolute temperature. Magnetic susceptibility is inversely proportional to the absolute temperature. Psi is the symbol of magnetic susceptibility, and T is the absolute temperature, must be into Kelvin. This relation was given by Curie at very low temperature.